Hey everyone, welcome back to Wrath of Math. I'm your host, Sean Ian. In today's video, we'll be going over some example problems of simplifying radical and exponential expressions. Sorry for this eyesore of a title slide, tough title to fit nicely into one page. So today, we'll be going over 4 examples, 2 simplifying radical expressions examples, and 2 examples of simplifying exponential expressions. Excited to get to this one. That one looks gnarly, doesn't it? As always, I encourage you to try to solve each problem yourself before looking at the solution. Metaphorically speaking, it's a lot easier to teach you how to swim if you're in the water with me. So let's go for a swim today and start doing some problems. So here we've got the square root of 288 minus the square root of 32. Now, when you're looking at the square root of a number and you're trying to simplify it, what you want to do is look at the factors of the radicand. The radicand is just the number under the radical. And in the factors of this number, we want to find a perfect square, because if there's a perfect square in the factorization, then we're able to simplify the expression by taking that perfect square out. And let me show you exactly what I mean by that. So what I'd notice first is that this is an even number, 288, so I'm going to write it as 2 times 144. So this expression is equal to the square root of 2 times 144, and then I'm going to do the same thing with this square root of 32. 32 is also even, so I'm going to write it as the square root of 2 times 16. So you see we haven't changed anything here. 2 times 144 is 288, and 2 times 16 is 32. Now in this case, as soon as I pulled out a factor of 2, we've got 2 perfect squares. If you still didn't have any perfect squares, you could try to keep on pulling out factors to see if you get a perfect square, but in this case, nice and easy, we pull out a 2, and there's perfect squares. 144 is 12 squared, and 16 is 4 squared. And when you're simplifying expressions like these without a calculator, of course it helps to be able to identify those squares quickly. So we are going to rewrite this expression like this: the square root of 2 times the square root of 144 minus the square root of 2 times the square root of 16. These two expressions are equal. And the reason we want to write it this way is because we know what these two quantities are. So now we can rewrite this as the square root of 2 multiplied by 12, because 12 is the square root of 144, minus the square root of 2 multiplied by 4, because 4 is the square root of 16. So now let's rewrite this one more time, moving the 12 in front and moving the 4 in front. Of course, multiplication is commutative, so the order doesn't matter, and I certainly prefer it this way rather than this way. And now what we're going to do here is just adding like terms. What would you do here if you had 12x minus 4x? Well, you would just write 8x. 12 minus 4 is 8. They're both being multiplied by x. You're just adding like terms here. So if we have 12 square roots of 2 and we take away 4 square roots of 2, we of course are left with 8 square roots of 2. And this is as simple as we're going to get it. So the square root of 288 minus the square root of 32 is equal to 8 times the square root of 2. Alright, so that's a fun little problem. Let's move on to the next one. Here we've got the square root of a plus the square root of b multiplied by the square root of a minus the square root of b. This is a pretty straightforward one. We just have to use the distributive property and do a little bit of simplification. So first, we multiply the square root of a by the square root of a. This gives us the square root of a squared. Then we multiply the square root of a by negative square root of b. Let me just move this down out of the way a little bit. So now we have minus the square root of a times the square root of b. Then we move on to the square root of b right here, distribute that. So we have square root of b times the square root of a. So this is plus square root of b, square root of a, and then we have the square root of b times the negative square root of b. So this is minus the square root of b squared. Alright, now we just have to simplify this a little bit. So square root of a squared, starting over here at the left, that's just a by definition. And then let's rewrite this. So we have square root of a, square root of b, plus the square root of a times the square root of b. So since multiplication is commutative, I just moved the square root of b and the square root of a around there. And then minus the square root of b squared, that's just b by definition. So what we did there, we said this is a by definition. We flipped this square root of b and square root of a around because multiplication is commutative, and we want it to match up with this minus square root of a square root of b. And then over here, we just have minus the square root of b squared. That's b by definition, multiplied by that -1, gives us minus b. So now, all we have to do is add like terms, because we've got a minus root a root b and a plus root a root b, so that's going to go straight to 0, and we're just left with a minus b. And this is beautiful in comparison to this. So, solid example there. Let's move on to this example of simplifying an exponential expression. Alright, so we've got 4a squared b squared multiplied by 6ab cubed all squared. First thing we're going to want to do is carry out this exponent here. So what do we get when we square 6ab cubed? Well, since the only operation in here is multiplication, we can just multiply 2 by the exponent of each one of these terms. So that's 6 to the power of 1 times 2, because it's originally to the power of 1. And then we've got a to the power of 1 times 2. And then we've got b to the power of 3 times 2. That's how all of that works. This, of course, is just equal to 6 squared, which is 36, multiplied by a squared, multiplied by b to the power of 6. So then we can rewrite this whole expression as 4a squared b squared multiplied by 36 a squared b to the 6th. And now, since multiplication is commutative, we can just multiply all of this stuff in the order that we want. So we want 4 times 36 multiplied by a squared multiplied by a squared multiplied by b squared multiplied by b to the power of 6. So now we just have to do this multiplication. 4 times 36 is 144, multiplied by a squared times a squared. Since they have the same base, we just have to add the exponents. So that's just a to the power of 4, multiplied by b squared, multiplied by b to the power of 6, and that's just, again, add the exponents, so that's b to the power of 8. So this is just equal to 144, a to the power of 4, b to the power of 8. And let me make sure that 4 looks like a 4. Yeah, not a 9, that's a 4. So this expression up here is equal to 144 times a to the power of 4 times b to the power of 8. Very nice. On to the next one. Alright, so here is the last problem. Definitely looks like the nastiest of the bunch. Now for starters, the first thing we're going to do is get rid of this negative exponent. So we can rewrite this expression as x squared multiplied by y to the -1/2 power divided by 2 times x to the power of 3 over 2 multiplied by y cubed, and all of this is squared. So all you have to do to get rid of that negative exponent is take the reciprocal of the fraction and raise that to the power of +2. That's all we did, was flip this fraction around, so the numerator is now in the denominator, and the denominator is now in the numerator. Now, since this whole fraction is squared, that's the same as squaring the numerator and the denominator separately. So we will rewrite this now as x squared multiplied by y to the power of -1/2. That is all getting squared, and that's divided by 2 times x to the power of 3 over 2 times y to the power of 3, all squared. Now, just like we did earlier, in order to carry out these exponents, we just have to multiply 2 by the exponents of everything in these products. So this is going to be equal to x to the power of 2 times 2 times y to the power of -1/2 times 2 divided by 2 to the power of 1 times 2 multiplied by x to the power of 3/2 times 2 multiplied by y to the power of 3 times 2, and close that parenthesis. So now this is equal to x to the power of 4 multiplied by y to the power of -1, and all of this is divided by 2 to the power of 2 multiplied by x to the power of 3 multiplied by y to the power of 6. And we got that by just multiplying out these exponents. So now we just have to simplify this a little more. There's three things we're going to do in this next step. First, we're going to square this 2 here in the denominator, because that's 2 squared. Then, notice we have x to the power of 4 and x to the power of 3. So, we're going to get rid of this x to the power of 3 in the denominator by subtracting its exponent from x to the power of 4 in the numerator. And then we're going to get rid of this y to the power of -1 by subtracting its exponent from the 6 in this y to the power of 6. So this is just using all of your quotient rules for exponents. So writing down here, let's first draw that fraction bar. In the denominator, we've got 2 squared, so that's 4. Then we have x to the power of 4 minus 3. And then in the denominator, we have y to the power of 6 minus -1. And this is just equal to x divided by 4 times y to the power of 7. So this is our final answer, most simplified form, x divided by 4 times y to the power of 7. And so really all we did there at the end was apply our quotient rules for exponents. We took 3 away from 4 rather than 4 away from 3 because we want to keep our exponents positive. Same thing with the y's. We took -1 away from 6 instead of 6 away from -1 to keep the exponents positive. Generally, when we're simplifying an expression, we don't want negative exponents. Just so you can see it bigger, this is what we got. This nasty expression simplifies to this much nicer expression. So those are just a few examples of simplifying radical and exponential expressions. I hope going through these examples helped you better understand the process. Let me know in the comments if you have any questions, need anything clarified, or have any other video requests. I'd be happy to do some more examples of simplifying radical and exponential expressions if you'd like to see some more. Thank you very much for watching. I'll see you next time, and be sure to subscribe for the swankiest math videos on the internet.
I lift the weight that's drowning me so I can rise up to the sea. I wasted half my breath on her, she's not wasting her breath on me. Rise like a phoenix from the ash, my lungs filled to capacity with